For this particular problem, we're determining what the z-scores are for two different tests and two different subjects, and then we're going to compare the z-scores to determine on which test the student did better. Here's the problem. The mean for statistics test scores is 64 and the standard deviation is 6.0. For the biology test scores, the mean is 23 and the standard deviation is 4.1. The test scores of a student who took both tests are given below. A student gets a 77 on the statistics test and a 28 on the biology test. A. Transform each test score to a z-score. B. Determine on which test the student had a better score. So we need to use the z-score formula, which is going to be x minus x bar divided by the standard deviation. For this one, the mean for the statistics test is 64. The standard deviation for the statistics test is 6. Hence the reason I'm using the notation x bar sub s and sd sub s, where the sub s stands for statistics. Then we have the mean for the biology test, which is 23, and the standard deviation for the biology test, which is 4.1. So let's find the z-score for the statistics test. That would be 77 minus 64 divided by 6.0. So 77 is the score on the stats test. The 64 is the mean on the statistics test overall. And the 6.0 is the standard deviation for the statistics test. This gives us a z-score of 2.17. You will round to the nearest hundredth for this one. Then we're going to find the z-score for the biology test. That's going to be 28 minus 23 divided by 4.1, which will give us a z-score of 1.22. Next, consider the fact that the z-score for the statistics test is greater than the z-score for the biology test. What this means is that the spread from the mean of the statistics test is greater for this student than it is for the biology test. In other words, the student did better on the statistics test than the student did on the biology test.